Okay, so when you want to write a program, what you basically do in the beginning, you draw a flowchart of the program, or you write the pseudocode of the program, and after you figure out what you need, then you start typing your code, right? So first you have to figure out what the program is asking you, and after that you start typing your code. Okay, in here we need to know one thing before doing all these things. We need to understand the concept or the meaning of having average of like n integer numbers. So for that, we basically need to know this equation. And I just write that. So average of some given number is equal to like the summation of those numbers, right? Sum of numbers divided by number of data. So mathematically, if you have a set like X, which consists of n1, n2, and n entry, and you want to calculate the average of it. So what you do is you just sum this up and divide them by n, because n is the index in here, meaning that we have n number of those integers. So we add them and basically divide to the number of the inputs or the data that we receive from the screen. So this is one thing that basically you need to know. If you don't know this one, it's going to be difficult for you to write the program. Okay, this is one thing. The next thing you need to know is how your program is going to operate, right? So this is a very simple program in terms of procedure. Just have like a few basic blocks, right? So the first one is read data from input, from standard input, right? Then basically store data in .pss, and then read the data and sum. Because reading and adding can be done using only one loop, and then divide by n, and then here you basically print out the result. This is the whole process that we need to do, but for each of these blocks, everybody may do different things, right? Someone may just, for example, for read the data, and it can be broken out like into a bigger block, right? So to do this, you basically send a prompt message to the user, right? So prompt to users to enter data, right? So basically you inform them to do that. So that's the first block. And then the user start entering the data. So, but you can do this in two different ways. You can send prompt for each integers that you want to read, or you can just send one prompt that basically you collect all the integers from the user. So you can do it differently, right? So basically, each of these blocks, let me write it with different color. Each of these blocks itself consists of multiple subblocks, right? So for example, in here, this can be broken into some subblocks. So you have to figure out how you want to do this thing in more detail in these subblocks, right? So since this is a simple basically program, we don't have much detail for it, but if you want to be more precise, just give it a minute or two, start thinking about each subblock, and write the pseudocode for each subblock to make your job easier. Now let's go back to Ubuntu environment. Any questions so far? Okay. Let's go back to perfect. Okay, just want to let you know one simple thing in Linux environment. So when you're writing your program, right? So simply you can open two windows, so that by going to the file, saying new tab, right? You can add tab to this. So each of these tabs, you can do different things, right? So for me, I just make it 2 tab. So for one of them, I open my program that I open my file that I want to write the code, and other one, I just use it to navigate between folders and check my files, all this thing. So for example, here is the place that I run my code. Just simply saying run.sh.sql. Now, since the scale file, this is the scale file that you guys have been using for your assignment and your lab. So to write your program, just open the scale file. So as you remember, we said that, okay, just write your code in this part, right? You come in here to basically write your program. This is a sample that we use for our program. Okay, since we said that the data has to be stored in the .bss section of the memory, so you guys need to create a segment .bss, right? So this is one of the segments that you guys need to basically create, right? So in here, what we do, basically we can define our variables in here, right? So for me, I want to make it more parametric. So I ask the user, okay, how many numbers do you want to take average for? For example, the user says 5, 10, 100. So in the exam, I ask you for 10 numbers, so you can just use that 10, not make it parametric, but I want to make it a bit more interesting in here, just by making this a bit more general, okay? So we use reserve double word for 10, for number n, and then there's my data, right? So I want to basically make space for the data. So I say reserve double word. Again, I'm assuming that the user the maximum size of the data that it's going to enter is 32-bit. So therefore, I define double word here, and I'm assuming that, okay, the maximum number that he may want to take average is about 100. So you can make this one as big as you want, 1,000, million, or any number you want. So for now, I assume that, okay, this is a number of data that we want to basically average. So a space for input data. So we are reserving some space for the input data. And here I provide comment that it's okay, this is the number of input data to the average. So when I write my code, I just simply provide some basic comments in the code to be clear for the reader. Okay, so this is the .bss section, so we are done with that. And then since we're gonna send some prompt to user, right? We define those data in the data section. So basically, let me see this. Okay, this one. I want to make this one as one tab so everything appears in the same order. That's fine. That is a bit big here. Okay, so I'm defining my prompt in here, input message 1. I say define bytes. For example, okay, I ask user how many numbers you want to average, something like this. So this is my first prompt, and then user is going to say something, for example, 10. Then I send the second message to the user saying that enter numbers. So this is the second prompt. So as soon as the user gets this, then he starts entering all numbers one by one until he's done. And then I have another prompt that let the user know that, okay, I'm done, and I'm printing out the message, basically printing out the average on the screen. So I say, okay, the average is something, right? Okay, so the average is this. Okay, so these are the messages that used to communicate with the user. And then we come to our main part of the code here. In here, we start provide some comments saying, for example, asking for inputting data. So this part of the code gonna be related to that. This has to be semicolon. Okay. Go and start in here. So what we do, we are going to use the book print macro. So as you know, we have print string, and print integer and read integer. These are the macro that we are used very often in this course to communicate with the standard input and output in assembly program. Later on, we learn how to implement this function using assembly by our own. Okay, for now, we send the first input message to the user. So to do that, we have to populate the EAX register with the address of that message in here. So that's the first one that we're gonna send to the user. So we do that. and then we call the macro, the print screen macro. So once we call this, it's gonna send this prompt to the screen and letting the user know that, okay, how many numbers you want to basically take the average. And then the user gonna tell us a number, right? Once it tells us the numbers, we need to read it. Therefore, we call read integer to read that number, right? Simple as that. And then as soon as we get that number, right, we want to save that number in memory. You can put it in some of the general purpose register, but we don't want to, you know, make one register just busy with just keeping this value. It is better to put it in the memory somewhere and make our general purpose register available to us for data manipulation and processing. So in here, we define one location in the memory to save that number. So we do that. So once we use the call read integer, that number is going to be saved in the EAX register. What we do, we take that number and we store it in the memory, right? So we do that, and now we have the number. And this time we ask the user to basically input the numbers, right? So first we need to communicate with the user telling that, okay, enter your numbers. For that, we say EAX input message to. Why? Because in here we define enter numbers, right? And this is the address for this, basically this data. So we get the address to EAX register. And what we do next, we call our macro to communicate this message to user in the screen. So print string is going to take that message from the memory and print it out on the screen. Now the user knows that it should enter the date. So I use print new line after the screen. So I want my cursor goes to the next line, right? Because if I don't, the cursor is gonna stay there, and then the user start inputting the data in the same line as the prompt. I don't want to do that. I want the user goes enter the data in a new line. Therefore, I send the cursor in the new line using this command. And then what I'm going to do is basically I want to read all those data from the input using a loop. How? So let's do this. I first load the number of the data that I want to read from memory location N into ECX register. Then I define a loop as a read loop. Read loop, this is going to be my label for that loop. And I start basically reading the data. Using what? Using read integer. So we do call read integer. So once we do this, we get one data from the user. Now, what I want to do, so I know that the data is going to be stored in the EAX register. Why? Because the read integer does that for us. It takes the data and it put it in EAX register, not anywhere else. It's going to be, so this is the way that the textbook macro is written. So once it reads the data, I put it in EAX register. Now, I want to move that data into the .bss section or uninitialized part of the programming here. Where? In a data section here. So for that, I need to dereference my data. So because that's the address, right? And I give it ECX as an index, right? And read the data and put it in there. So as I'm writing the program, I purposely put some typo in there so that together we can kind of do a bit of debugging to figure out what's going on. Okay, so we do that. So we move the data into ECX. Yeah, basically we read the data. The data is going to be in the EAX register. Now we want to take each input and put it in a uninitialized section of the memory. How we do that? We just use the pointer to the memory with this data. And since we want to wanted to make an array in the data section because the data is an array, right? So once we move, once we read the new data, so we need our pointer to point into the new location. That's the reason we use ECX register to do that for us, right? Okay, perfect. Then simply we do loop, read, loop. You guys know that this loop instruction is a very interesting one. This works on ECX register. What it does, basically, it checks the content of ECX register and sees that if ECX is greater than 0, it's going to repeat this read loop. As soon as ECX gets to 0, it's break this loop and goes to the next line. So one of the other things that loop does, it decrements the value of ECX register automatically. So if you don't know this, please go and do a bit of review on the loop instruction. This loop does the decrement on ECX register, and it's in kind of a jump instruction. It's check the ECX register and jump to the label. It does 3 things. Decrement ECX, check the content of ECX, and jump to the label if ECX is not 0. So that's a very good, basically, assembly syntax, very versatile. That's the reason in here, I use ECX as an index for myself. Okay, perfect. So let's basically run this and see if this works. So we save it, W. I don't close it, I let it be open, and I come here and run it. So once I'm running this, it says that how many numbers you want to average. I say, for example, 3 numbers. And then say, it says enter the numbers. As you can see here, the cursor goes to the new line because I add a syntax called print new line so that my numbers doesn't appear in here. I don't want my number be appearing in here, the cursor in here. I want it goes to the next line. So what is your first number? For example, 1, 2, and 3. So that's done. But I want to know whether basically my data is going to be stored in the memory, right? So how do I do that? Before I move to the next one, I want to make sure that the data that I'm reading, it's basically will print out. It's going to be stored in the uninitialized section of the memory. How can I make sure that? So one thing that we can do is basically to print out the data, right? So what is the data that we want to print out? This data. Let's see if the data that we are reading basically is the data that is stored in the memory. So to check that, we basically simply print those data on the screen. So this is just for debugging purposes. So just to let you know that the debugging in Linux environment for C and assembly can be done using GDB. So that's the debugging tool. So once we are compiling our code, we have to give it some switch so that the compiler create a debugging file for us. So once those files are created and we run the program, we can step into the line by line in the Linux environment and see what is in the memory, what are in our register, what are the content of the stack, and all these things. If you guys haven't been done debugging in C environment, it is a bit tough for you to do it for assembly. So I used to teach GDB in the CSUCI when I just arrived here last year. But since some students are not familiar much with Linux environment and they haven't been doing basically debugging for C in Linux environment, they find it very difficult to do that. So that's the reason I'm just here providing you some very basic method of debugging to do debugging in the Linux environment. But do you really need to do debugging in Linux? Because it's not easy. Just search it in the internet and say GDB debugging assembly. See how many resources you can find in the internet. Not much, because it's not an easy task. It needs patience. It needs time and hard work to be master in that kind of things. Some may argue that, okay, so why we need to debug like assembly and C code like in the Linux environment if that's a bit not very straightforward. We can use, for example, Visual Studio, just run our C program and then go through that step by step and check the content of our array and memory and so on. So the answer to this question is that in real life, when you go working for some companies, and if they are working on some like software that's going to be run using a mini operating system, and it has to be done using Linux and command line, you will see that that's one of the reasons that you need to do the debugging in such environment. The second thing is that assume that you're writing the program that can be basically run in both environments. Then if you want to do the debugging using Windows, the problem is that Windows do some memory management for you. So if you do not, populate your memory correctly, sometimes because of some tools that provided in Windows, it does that for you automatically so that you don't get segmentation fault. So if you write a program that is supposed to be in Linux environment and then you are going to be, debug it using Windows, you never catch, if you get segmentation fault in Linux environment, you may not get the segmentation fault in Windows environment because Windows does the memory, some level of memory management for you. And you never be able to do the debugging for that system. So this is the reason sometimes it is required to do the debugging in Linux environment to catch those things. So that's a must. So if you learn how to do the debugging in Linux environment professionally, it's going to be very useful sometime in the future if you choose a career to write some, mini operating system or work in this area in the future. Okay, enough talking about that. And so let's come back to this. We said that we don't use GDB, but if anyone interested to use GDB, just let me know to send you some materials so that you can go through and learn how to do it. But for now, using this macro that the book provided, print integer, print string, read integer, so you can do the debugging, and even you saw that you can also print out the content of all the registers, the stacks and everything. So this is gonna make the debugging in assembly very convenient for you guys as a beginner. So let's do that. So right now we want to print out basically what we read and stored in the memory. Okay, so let's do that. So to do this, what we basically want to do is something else. We want to take the contents of those memory, uninitialized memory, data plus ECX, and simply we print it back to the user, right? We print that, print integer. So we have to call that, call print print. right? This is the macro, right? I forgot exactly what was it. I'm guessing it's the macro. Okay, what we do, we basically read the data, we put it in the memory, and we want to check whether the thing that we read is basically stored in there. So what we do, now we take that value, put it back in EAX, and we want to print that out. These two lines is only for debugging purposes for this loop. It's not going to be included in your program. Let's run that and see if what we read basically is stored in the memory. Set how many number? We say 3, 1, and it's gonna be 2. It's going to be 3. Okay, so it's weird now. So what do I want to do in here? Okay, we run it again. 3, 1, 2, 3. So enter 1, it's print out 1. We enter 2, it prints out 2, and we enter 3, it prints out 3. Okay. So it seems that whatever we write is going to be written back for us. Okay. Data is a double word, 100. We have ECX. Okay. Okay. So this is one set of data that we tried. Let's try bigger numbers, right? Let's try, for example, 1,000. And print out 1,000, print out like 2,000. Okay. And print out 3,000. That's fine. Okay, now it seems that our memory is okay, right? So to make sure that, let's do something else. Because right now what we read here is the content of data ECX. I'm thinking that this might not be the proper way to do that. Let's write all data in the uninitialized section instead of like element by element, and then write another loop to see if all those data are properly stored and not overwritten, okay? Because right now we are checking element by element, and we may not be able to catch that, right? So basically we remove that. We check the okay. So this is the loop that we are writing the data. Now, since we are working with arrays, we want to know when we read the data, basically the new data doesn't destroy the previous one or the next one. Okay, let's check that. So this time we basically write another loop, say debugging loop. The debugging loop. We don't need to read again. We just want to read from the memory and see the data that we are basically right in there is still there intact. So again, we need our index register, move ECX, and because the content of n ECX is right now 0 after exiting from that loop, so we're gonna do this. Use the same index, called print and loop and debugging loop. Okay, there's a typo in there, but as long as both labels are the same, it's fine. Okay, we save it. This time again, we say, for example, 3 number, 1000, 2000, and for example, 8. So 3 numbers in there. Now we read the number from the memory. As you can see right now, my first number is 0, second is 0, and last one is 8. So the first 2 numbers basically are, you know, removed somehow from the array, right? So therefore, I'm not writing the data properly in the memory. So let's, okay. Let's run the program again. This time with a smaller number, 1, 2, 3. As you can see, the first 2 data are kind of 0, where we write this 1, 2, 3 data. Anyone knows why this is happening? If you go back to the program, right? So when we define the data, we define reserved double word, meaning that each element in the array is 4 bytes, right? And we know that the memory is byte addressable. So we can access byte in the memory. We can now take a look at this one, right? When we read the data EAX and then we move it to the memory, right? We move it to data plus ECX. ECX first is n. For example, if your n is 3, is data plus 3. And next time going to be data plus 2. And next time going to be data plus 1, right? This is basically the address of the byte in the memory. But what we want to, for the pointer to do, is point to memory elements, 4 by 4. For example, if the first element is at location 12, we want the second, the pointer in the second time point to the location 8. And next time point to the location 4, for example. Or if you are increasing in the order, first one should be location 1, second one should be location 4, 8, 12. Basically, it should be incremented by 4, right? Now it doesn't do that. It's going to overwrite the data in the first location in the array, in the data array. That's the reason your last element only is going to be written in there. So how do we fix this? We need to fix our index, right? We need to fix our indexing in here. So when we point to this array, so how do we do that? We just increment by 4. So there's one way to do this, just multiply ECX by 4. The other way is to use different mechanism for your loop, and you add 4 to your ECX register, you use jump instruction and all this thing. But to simplify the program, we do this. We basically multiply ECX by 4. Okay. Perfect. Now we do that, and let's see this time if the program works. So we write the data, and we are hoping to get the proper data back. So 3 numbers, 1,000, for example, 2,000, and 3,000. These are the 3 numbers that we're writing. And as you can see, right now, the program is working properly. It prints out whatever we written into the memory. Another one, again, 3 number, 1, 2, and 3. And as you can see, it's written back the 3 numbers for us by going through the array in the uninitialized section of the memory. Okay, we checked that. Now you can basically get rid of this section of the code, or you can let it be there. Maybe later on you again need to use it. Now let's go ahead and go to the other section. So now we put the data in the memory. What we need to do now, we need to read those data from the memory and add them up. So we need another loop. So we call this like sum loop. Let's call it sum loop. And okay, before doing to the loop, we again need to initialize our ECX register with number n, the number of data. So we put that back because the content of ECX right now it's reduced to 0. And because I wanted to add all data into register EAX, I'm going to simply initialize that EAX with 0. So now I'm going to read the data from the memory and basically add them. So I read the memory data from the memory. I put it in EBX register. So data plus 4 ECX. So now I take one element and put it in EBX register. Next line, what I do is I add EBX to EAX register, meaning that the previous value of the sum is going to be added to EBX register now. And then what I do is just loop into sum loop. So what this loop does, it takes the data element, put it in EBX register, it sums the previous value of EX register and add the new value EBX register. Let me see if I can write something in here. Okay. So this mathematically, it's, or if you want to write it in C, it's synonym to this command. Sum, it's basically what it does. Let me put it here. So this line is something like this. Sum equals to sum plus the new number, some number. So number is going to be in the EBX register, right? And sum is going to be in the EAX register. Sum is in how do I write this? Just write sum is in EAX and number. The new element is in EBX register. As simple as that. And loop, what it does is this. It decrements ECX, it check ECX, let's say compare ECX with 0. If not 0, goes to loop. So loop does 3 things for us. Okay, perfect. Now we're done with that. one thing that we can do is basically use a print statement here to make sure that basically the sum is the sum that we are expecting. So what we're doing here, we just call print int. Let's get rid of this. We are going to print the content of EAX register and see if the sum is printing properly. So basically, this is the thing, the procedure you guys need to do. So don't write your program in one shot, just write it piece by piece and test. So let's do this one. So enter three number, 100, 200, 300. So as you can see, the sum is printed out in here and it is 600. So the sum is okay now. Next step that we need to do is the division, right? So I put the label here as division label, but it's not going to be a loop. It's only a label saying that here division is happening. It's not a loop. Before I go to that, again, I want to use my ECX register in division operation. So move ECX n and then move EAX 0. EDX, we have to initialize EDX with 0. Why? Because we're going to do the division operator, and you guys know that the division is going to be applied on the concatenation of EDX and EAX register. So basically, whatever is in the concatenation of the EDX and EAX register is going to be divided by the operation, by the operator, by the argument of the division operator. So we say div, right, ECX. What does this mean? It means that whatever is in the EDX and EAX register is going to be divided by the content of ECX register. And what is in the content of ECX register is the number of data. Basically, we have sum, and we now divide it by ECX register. That's it. So we do that. Now, now we want to print that out, okay? So let's print that out. Okay, just a second. Okay, so once we do this, divide ECX, then the quotient is going to be stored in EAX register, and the remainder is going to be stored in EDX register. We don't need the remainder, we just need the quotient value, which is the average, right? So let's print that out. Okay, what we do is say, first we have to send the command output prompt to the user, letting him know that, okay, basically we are printing out the average. So we use what was that prompt? Okay, is this one, right? So you want to say the average is something. Okay, so we go output message. So we put that in here, output message in EAX. And then we print, we call print, okay, print a screen to let the user know that basically we are doing this. Okay, and then we basically call print integer to print the result false, right? Let's run it and see if it's working. Okay, output message undefined. So let's see why is this. Let's go back to the top. Yeah, it's correct. Because there's a typo in here. We say OU put. There's the T missing. So let's say that. Come back and we run. How many numbers? Let's say 2 numbers. First number is 50 and second number is 50. No, not make it 50, that make it 30. Okay, so the sum is 80, but the average is something like this. Why is that? So we come here, since the sum is printing out correctly, we get rid of this line. Don't need that. And we come over here, call print string. Let's make a new line here. New line. We haven't fixed the problem yet. Let's just run it again for. One run 2 number, one is 100, one is 200. The average should be 150, right? Now it says that the average is this weird number. Anyone knows what the issue is? Let's go back to the code. So we are here. We print out the output message, right? And then we call the macro to print our results. And for some reason, this doesn't work properly. Anyone does have any answer for this?
Is it because ECX is not in brackets?
No, for E6, you don't need a bracket for E6 now, because E6, the content of E6 is the value n, right? And if E6, you wanted to use it to point out to a memory location, you need to put the bracket. In here, we need the content of E6. Therefore, we don't need to use a bracket. Any other solution? So let's see what we have one in the chat. So once I'm sharing, for some reason, I can't see the content of the chat. Okay, now it's coming back. You move out MSA output message into EX register and print out what is in EX register. So Fernando, thank you very much. That's exactly the problem. So Fernando pointed out that in here, we have the average basically stored in the EAX register, right? Okay, let me tell you that. Let's get rid of this code. We don't need this. These are the debugging code. We don't need them. Come up. Okay. So Fernando is saying that, okay, you calculated your average in here, right? Now my EAX is going to be equal to the average value. How do we calculate that? You have the register EDX concatenated with register EAX. You divide it with the content of register ECX. And the results, once you do this, the result goes to basically EAX. So the result is in EAX, right? So Fernando's saying that you have the register EAX, but you overwrite the value. You put the output message on it. Now EAX is having the address to the, basically the address that's pointing out by this pointer. Now you print out the output prompt. And again, when you call the print integer, what is going to print out for you is the, whatever it is in EAX register. And now the thing that is in the EAX register is basically one address from the memory, not basically the result of the average. So how do we solve this? Anyone has any solution for this? You can speak out or put it in chat.
Or you end up moving EAX register into a different one?
Exactly. So, and then
just moving it back after you print out the message.
thank you. I didn't see your name. What's your name?
Angel?
Angel. Okay, thank you, Angel. That's a solution. He says that we make a copy of it, put it, for example, in EDX register, and now we have a copy of it in EDX register. Now our EX register is free, so we can use that. Yes, there's a typo here. So we can use that. Now I want to print that value out. Since print macro work with EX register, I'm moving back EBX into EAX after print out the prompt message for the user saying that we are printing out the average. So we get that, and hopefully this time it's working. Let's see if the engine solution is working. Okay, two numbers. I want to print out 100 and 200. Yeah, so 100 and 200 is 300, and the average is 150. It's correct. Okay. Thank you, Angel. So your solution was perfectly correct. All right. So in the question, in the exam, we said that calculate the average of 10 numbers, right? Average of 10 integers. So let's try that. So give it 10 value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the average is 5. That's correct. Okay, now we said integer numbers, but integer number can include negative number as well, right? So therefore, your program should work also for negative numbers. Let's try that and see if it works for negative number. In the exam, then I correct your answer when I graded your answer, the program basically. I didn't enforce this one that the program should work for negative numbers. As long as it worked for positive number, I give you a full grade. So let's now try this and see if this works for basically negative number. Let's take two numbers. Only make it like very simple. 1 and -2. Wow, the average is this. Anyone knows what's going on? Just guess, it's okay. So now we are getting a weird number. We know that we write the data into the memory properly. Our summation was kind of okay. Let's see. All right. Okay, Ellie said use iDive, and Ivan also says dive not work for onsite. Yes, both of your answer, Ivan and Ellie, is correct. So div work for unsigned value. Let's go back and apply the suggestion from Ellie, Ivan, and your other friends. So let's change this. So we use iDive so that either work for positive and negative numbers, right? And check that. We fix it now. We check two numbers. So let's see if it works for positive number 2 and 4. Yeah, the average is 3, works for positive number, and see if what works for negative number 1, for example, -3. So the average should be -2. Okay, still the average is this weird number. So what we do? Okay, once you reach at this point, right, you have to trace back your program. One thing you need to know is first print out the sum, okay? This is the step exactly before the division, right? Let's see if the sum is okay, right? So to do that, we print out the value of the sum, print in. Since EAX contains the sum value, we use print int, it's gonna give us the, basically whatever it's the sum value. Okay, let's see. Let's run that and see if we get proper value for sum for negative numbers, okay? You need to trace back, and if sum doesn't show you proper value, then you have to step back again. Okay, so we have some weird error message in here. Okay, it says that a line without a column might be in error. And it says that scale .asm line 44, right? So take a look at the error message and then we go to the first one. So we need to set the number for our program. So we use set number and we give this number in the screen so that we can take a look at the error. So it was line 44. We go to line 44. Okay, so we have these two macros in here. So what is the issue? Why these two macro doesn't work? Okay, we have one answer. Here, let's see. Please. Okay, missing call in front of them. Thank you, Owen, exactly. So you just add call print and call print. So we miss basically the call command. So basically you need to communicate with Linux to understand what's going on. Okay, now it's good. So we say, we are testing if the sum of the negative number work properly. So we say two numbers, one number is -100 and the other one is 200. Another one, let's say 300. So the sum should be 200, right? As you can see, the sum is okay. So that's a good news. So it means that your memory and everything is fine, summation is working fine. But the average, okay, so since the since the sum is positive, the average also is okay. So let's check another number so that the average is negative. So this time we say two number. So first one is 100 and second one is minus 300. Okay, as you can see here, the sum is fine, okay, but the average is still this weird number. So what's going on, guys, here? Okay, since the sum is working properly, we remove this debugging line here, and we come back to this division. We know that some issues in this division. We first check if I dive basically work properly for a negative number, and we know that it's work for negative number, but still it doesn't work. So what's the issue? So let's try another number. So since we don't have time, I don't want to take much of your time of the lab and do the debugging a bit faster. So again, this time two numbers, right? So this time we say one number 2, -2, and the other number is 1. So the average, let's see, I want to make -2 and minus. I want to simplify this one, okay? So let's do 0. So the average should be -1. So the sum is okay. Why you are printing the sum again? Remove that line, right? Okay, maybe we didn't save. Let's do it again. Two number, first number -2, second 0. Okay, now the sum is gone because we didn't save the previous. Okay, now the number is this weird number. So let's copy this number, copy. And so the average should be -1, right? See, what is this number in hex that is printing out for us? We can convert it back to basically hex, right? Now, so you can see this number, right? Okay, this number. 7FFF. What is this number? This number is shown as a positive number because the first significant bit is basically 0. But when we are having -1, -1 should be, if it shows it -1 in hex. Do you guys know what -1 is in hex? In a 32-bit number? Is FFFF, right? Is 8 basically F, 0x FFFFF. It's like that, right? So it means that something going on with our the content. So our content, when it's divided by 2, it doesn't do the sign extent for us. And the sign somehow, as you can see from the previous one, the sign is positive. It is this one. The first number is 7. So this means that this number is positive. Therefore, before you put your number in EDX and EX register, If you remember, we said that we need to do the sign extend. So if your number is not sign extend, then EDX content is 0, and ECX is 1 something, is negative, but when you divided that by, for example, 2 or n, that one goes away, and your sign bit changes to 0, and therefore the system interprets that number with the positive number. We don't want that. So we don't want that. Therefore, once we put the data in the EAX and EDX, so we do the sign extend for EX. And in one of the lecture, we said how we do the sign extend for EX register. So basically, when you do CDQ, if your content, the content of EX register is a negative number, then EDX register is going to be populated with 1s. So its content going to be all F. So, and when you use IDIE, once assembly sees that the content of the EDX register is F, the most significant bit of the EAX register is 1, it knows that this is a negative number. So once it's do the calculation, it keeps track of that negative number. So it take a look at its argument, first ECX, and it take a look at the divisor, and it keep track of those negative numbers. Let's see if CDQ correct these issues for us by extending the sign bit into EDX. Let's run that. It's here. So we said, okay, 2 number minus 200 and 50. So the result should be 150, and divided by 2 should be minus 75. So now, as you can see, it's print out properly the result of the negative division. Perfect. Any question? All right. Let's save this one and go back to the lab and see what we have over there. Stop sharing this. Let me open up the lab. Lab 8, I think. Okay, that's the interesting part. Okay, as we said, this chapter is about like bitwise operation, and you guys need to do some like data manipulation in bit level. Okay, let's see how we can do this. If you listen to the previous lecture, we said that how you can set a bit in a given data, set a given bit in a data, in a register or in a memory, or how you can unset that, or how you basically can flip a bit. Okay. Let me go through the lab and then I come back to the technical part. So in this lab, so you are asked to find the pattern 10. Let's see. Okay. The annotation, yeah. Okay. So this pattern. So you have some data, you are reading some data from the input, from the keyboard, like this number, 5386, right? Basically, you can convert that number into binary, And what you are asked is to find the pattern, this pattern, 101 in the data. If you take a look at this data, so the 1 zeros are arranged in this way. So there are two instances of 1010 in this data stream. So your program output should print out the number of occurrence of 1010 as an output. If you take a look at here, there are 3 occurrences in here, and what's the reason? Because this is the first one, this is the second occurrence. And if you take a look at this data, it's 101010, right? Therefore, this is also a 1010 pattern. So we are counting basically the overlapping pattern as well. So we said that your program should count the overlapping pattern, because writing the program for the overlapping pattern is much, much easier than the non-overlapping pattern. Okay, so your program should output this thing. So it takes the number. So as you know, then once the number are in the system, they automatically be converted to 0-1 string. So you don't need to manually do that. But in order to test your program, you need to know how many of these occurrences it has. Therefore, on the piece of paper, when you are submitting your report, for example, you have few data as an input. So in your report, you need to do this conversion to this data stream, and then show the output screen, the output, the screenshot of the output, and say, okay, for example, 470 I converted that into bit stream, and it has 1 occurrence, and therefore my output showing only 1 occurrence. So this is a simple program. So let's see how you can technically do this. You need to use some jump instruction and some loop instruction to do this. Let's take a look at that. Okay, so whiteboard. All right. Okay. Let's start with very small sample. Assume that you have 4-bit number 0101. And I want to set this value 1. Therefore, I want to convert this into this string 1101. Okay. So you guys tell me, using the logical operation like AND, or XOR, how can I do this? We'll start with simple example of manipulating data in bit level, and then we move to that example how technically you can do this, okay? Okay, if I want to set this bit, right? If I want to set this bit, so what I do, this one is a 4-bit number, right? If I do this operation 1010 and OR it with this number, sorry, let me put a bracket, and OR it with this number 0100. Then what happens is that it's going to do the bitwise operation, 0 with 1, and this bit with this bit with that, and this bit with the last bit. So the first 2 operation, or this with or this, is going to be 1, the same digit. The second one, this and this, is going to be 1. And the last 2 are going to be 1, 0. You see that how using a simple OR command we can set a bit in a given register, right? In here. So this is one example. Second example, assume that we want to basically unset this bit, making it 0. And we wanted to have this value, 1, 0, 0, 0. How can I do this using this logical operation, the basic logical operation? Which command I should use and how? Okay, this is simple again. This time you use AND operation, right? Use AND operation, you have your first number. So we have one answer here, let's see. From 1, if you use 1001. Yeah, we use AND, but the number that we AND is different because we want to make this bit 0, the second bit 0. We AND with the bit stream that its second bit is 0. So basically, we take our number 1, 0, 1, 0, and then we have to AND it with a bit stream that its second number is somehow 0, 1, 1, 0, 1. If you do the bitwise, so first one going to be AND with the first one, so the result is 1. Second one is going to be AND with the second one, so the value again going to be 0. But third bit is 0. It's AND with 1, the result is going to be 0. And since the last bit is 0, AND with 1 is going to be resulted in 0. Right, so this is what we wanted in here. Okay, perfect. Now, what if we want to do the bit flipping, right? You have 1, 0, 1, 0. You have this one. You want to flip all the bits. They make it like 1, 0, 1, 0, 1. You basically flip the bits. If it is 1, you change it to 0. If it is 0, change it to 1. So how do I do this? Flipping. Okay, if you want to flip a bit, anyone have answer for this? Using logical operation as a hint, AND or XOR. So as to these two cases, you have number 1. If you XOR it with 1, the result is going to be 0. So it's basically turn 1 into 0. If you have number 0, if you XOR it with 1, the result is going to be 1. Therefore, XORing numbers with 1 is going to flip those numbers for us. Now, if I XOR 1, 0, 1, 0, XOR with bit stream 1, let's put it in bracket, 1, 1, 1, 1. Then what happened is the first one is going to be XOR with the first one. The result is going to be 0. Second number with the second bit, result is going to be 1. We repeat that for the other 2 bits, you get this, which is basically what we want. Okay, these are the 3 simple operations that you guys might need when you do the... any question in here? Okay, perfect. Now let's go back to our example for the lab. So you have bit stream like this, and we wanted to find this pattern, right, in the bit stream. Assume that we have 1 0 1 0 in here, and then we have some bits 1 1 1, and here we have 0 0 1 1 0 0 1 1, for example. So we have one occurrence here, and basically we want to catch that and output saying that, okay, we only have one occurrence in our data stream. So how do we do this? The procedure is very simple. You read the data 4 bit by 4 bits, right? You take first these 4 bits, and then you compare that 4 bits with 1 0 1 0. If it is equal to that, then you say you count 1. For the first case, we see that no, it's not equal to that, therefore the count is staying 0, right? And then what you do, you shift for 1 bit to the right. Therefore, it's going to be falling, and your data is going to be shifted. Now your data is going to be like this, going to be 1 1. 1 is falling down in here, and then your occurrence is going to be moving 1 bit to the right. Okay, now again, you take the first 4 bits. First 4 bit is this, and then you compare. So it's only 1 0 1 1. You compare with 1 0 1 0. Is it equal? No. Therefore, the count gonna stay 0. You don't count. Count gonna stay 0. Then what you do, again, you do one more shift. If you do one more shift, let's write it over here. Is there? Okay. You do one more shift. Draw. So if we do one more shift, then we are going to have this one, and our pattern now is in here, 0 1 0 1, and then 0 0 1 1 0 0 1 1. Again, you compare. You will see that the first 4 bit is this. You compare that 0. So that is going to be 0 1 0 1. Is it equal? No, it's not equal. Count stays 0. Therefore, you go and do one more shift. Okay. So you do one more shift. So once you do one more shift, this bit gonna be falling, and then our pattern gonna be staying here. And then we have the rest of the bit here. 1 0 0 1 1. So basically, this from this part to filling out the register with 0 value. Okay. So now you check. You check. You have 1 0 1 1 0 1 0. Is it equal? Yes. Then the count is going to be 1. You do this shifting again until you finish in here, right? If you are having 32 bits basically register, you need to shift it for about like 31 bits. And since this is a 4 bit, you can complete your shift in after 28 bits. But for now, you assume that you want to shift for 31 bit and check every 4 bits when you are shifting, right? And then you increase the count, and simply you print the count value on the screen as your output. Okay, when you're writing your program, right, this value is 1010. So in hex, this is 0xa. So when you do the comparison, you basically compare that 4-bit with A. If it is A, you increment the counter. If it's not A, then you just let the counter be at what value it is. Okay, so this brings us to the second question, which is, okay, how do I shift and how do I compare, right? So let's do that. So the first operation is shift is easy. You shift to the right. You can use SHR command. That's easy. And the second things you need to know, right? So once you shift it, and let me write this again. Once you shift your register, assume that this is your EAX register, right? You basically do the shifting, SHR, for example, SHR EAX like 1, right? Check the SHR command to know how to shift for how many bits, okay? You shift it, and then you want to check the first 4 bits, right? So what you do, you have to mask the rest of the bits. You have to mask the rest of the bit and make them 0. But if you mask the bit in EAX register, then you lose your data. So what you do, after you do the shifting, you move the content of EAX register into EBX register and mask the EBX register, right? Now this content, for example, after shifting is right now in EBX register. So EBX register right now has our pattern 1010 and has the other bits, right? 10011, and the rest is going to fill up with 0, right? And this is some numbers, right? But we don't want this rest of the numbers. We only want the first 4 bit. So we want to mask all this, right? Now I have this EBX register. What I do is use the AND operation. I use the AND operation to make all these top bits 0 and only keep this 4 bit, right? Therefore, I AND EBX register with some numbers. Now, can you guys tell me what that number is? So I want to get rid of all bits except the first 4. With what number I should AND this register? That's the only key point that this lab has. The rest is using the shift command and just jump instruction and do a loop to do the shifting and repeating the process. It's very simple. I'm looking for one answer. If you give me that answer, we can kind of conclude this lab session. I am waiting. I wait until I get the answer, okay? So somebody needs to jump in. If you don't understand the question, ask me to clarify more. Okay, so we have some answer in here. Okay, Cody said, is it 1? If we do AND with 1, we only get the first bits, and the rest of the bit gonna be 0. Since we need 4 bits, Mark pointed out that we should AND with 111B, and that's correct. Perfect. So this is what we wanted. So we AND EBX with this number, 0xF. Basically, we AND that. So all these AND with 1, 1, 1, 1. The rest is going to be AND with 0, right? So the rest is going to be 0. Therefore, the content of EBX register is only now having 1010, which is in hex is 0xa, or in decimal is 10, right? Once we AND that, then we compare basically with CMP, EDX with 0XA. And then I don't want to write the whole program. And then you increment your counter if the result is equal. Okay? So you can say jump equal, then go to the counter and increment the counter. If not, then go to the loop, do it again. But remember that you also need to keep track of the length of your register for which, for this case, you can assume it's 32 bits, and you need to shift it until for the last 4 bits. So shift until you get the last 4 bits. And after that, you can stop. Therefore, you can set the counter like your ECX counter, for example, or EDX counter, fill it up with like 32 or with 28. Both of them are fine. And as soon as you get to ECX, you know that you are done with this number. You shift it all the way to the right, and right now the content of the EX register is getting to 0 back. So it means that you check all the possibilities. Any question? Okay, go ahead and start writing your program. And in case you have any question, please feel free to post it in the discussion board. And then you can find the answer in the discussion board. If you don't find the answer there, and if I do not respond, please feel free to reach me, okay? Feel free to send me an email and let me know what the issue is so that I can help you to figure it out. All right, thank you, everybody. If you have any question, please stay here in the chat. If you don't have any question, please feel free to check out, and have a great weekend.